Okay, I guess now I'm audible to every one of you. So thanks Rahul for telling me this. Now let me start again from starting. So as I was saying that we have already covered how to find a cycle in undirected graph. Now the question for you guys is in while finding cycle. Okay, let me go back. While finding cycle in directed graph, number one is which data structure we use. Structure we used, and number second is which traversal technique we used. So I want you guys to answer these two questions either in the live chat, or if you're watching this video later on, then you can answer in the comment section. Now coming to this undirected graph, as I was saying that the cycle which you can see over here is B D E B, right? So to find this cycle we have different techniques to do so we can either do it using topological sort, which I have not taught you yet. I'm gonna teach this thing later on. Okay, next one is BFS traversal, next one is DFS traversal, next one is disjoint sets. Okay. So these are the techniques that I used to find these are the different techniques by using which I can find the cycle in my undirected graph. But in today's class we are going to focus on BFS. We are going to use breadth first traversal for finding the cycle in our undirected graph. Now I again have a question for all of you, that in BFS traversal which data structure we used. Quickly tell me that which data structure we used in BFS traversal. So let me just name it with today's topic. So today's topic is finding cycle in undirected graph. Okay, so you guys can quickly tell me that while doing BFS traversal which data structure we used, and then I will move to the algorithm. Okay, so now let's move to the algorithm. So the first thing is the data structure that we use for BFS traversal is Q. Okay, now here I'm going to maintain one Q. I'm going to maintain a flag which will have values as 0, -1, 0 and 1. So -1 is when unvisited. Again, -1, any vertex will have value -1, flag value -1 when that vertex is not visited. 0 when visited, and in Q, and 1 when popped out of Q, Q, and जब Q से बाहर निकलेगी हमारी तो obviously it is visited, and it is also in the set, our set. Okay, so I'm going to maintain a Q, also I'm going to maintain a set which will have other answer, or you can have the answer in array also. आप array में भी answer डाल सकते हो और आप set में भी answer डाल सकते हो. Okay, cool. Okay, let's start with the traversal. So initially all the vertex will have -1 as the flag value. सबकी flag value क्या होगी? -1. Yes. Now when I can start with any node. Here I'll start with A. Okay. Now what I'm going to do is I'm going to okay, what let me do a little bit change, because this graph is exactly same the graph which I taught yesterday. So let me do a little bit of change over here and let me attach it like this. Okay, cool. Now yeah, let's start with A. From A, now I have visited A. Okay, this is my queue. Okay, I have visited A. Now this will become 0 and it is in queue. Now I have two options. A से मेरे को जाने के two options है, एक B है एक C है. Okay, so what I'm going to do is I can go on either side. Breadth first traversal का मतलब क्या होता है? We are going to explore all the vertex which are attached to our current vertex. So इसके जितने भी neighbor vertex हैं हम उनको पहले explore करेंगे, तब फिर next vertex की तरफ बढ़ेंगे. Okay, so when I'm going to remove it and move to our set or move to our answer, so क्या करेंगे हम A को यहाँ से हटाएंगे, A को set में डालेंगे, इसकी वैल्यू यहाँ से 1 करेंगे, and while doing this we are also going to see the neighbors of A. So the neighbors of A are B and C. I can either go like this B and C or I can go C or B. It's totally my choice. B और C लिख दे रही हूँ मैं अभी के लिए. ठीक है. Now because we have pushed 0 B and C in Q, so I'm going to change the flag value from -1 to 0. Right. Now the next value in the Q is B. Now when I will see wait, just give me a second, guys. Okay, cool. Now this is B. Now when I will remove this B from here, I will put it inside the set. This set will be the answer. ये set हम print करेंगे. Okay. Now I will see all the vertex which are neighbor of B. So the vertex which are neighbor of B are D and E. So what I'm going to do is I'm going to put E and D. आप किस order में इसमें push करोगे, that is totally your choice. Okay. Now next is C. I will check if we have any. Okay, now once I have done this, this will be changed to 1. Okay, now I'm going to go on C का कोई neighbor है या नहीं. So C doesn't have any neighbor. So what we are going to do is we are just directly going to remove it from here. We are going to put it inside the set and we are going to change the value, flag value as 1. Once I have put E and D also, I'm sorry, I just forget to maintain this. The values will change to 0. From -1, it will change to 0. Now the next value will be E. Now when I will go on E, it will check the neighbor values. So जब हमारी B हमने चेक किया, E के neighbors क्या हैं? B and D. So B already has value, flag value 1, which means it is like it has been already in the queue and it's also been printed. Now one other neighbor that we have a cycle in our graph. Okay guys, so this condition, if flag of V, like V is the vertex, is equals to 0, then that means we have cycle. Okay. Now otherwise, if we'll also have conditions like if flag of V equals to 1, then that means we have already printed. Okay, so here we just have to continue. We are not bothered with the value 1. जब 1 होगी तो we are not bothered because that is already visited and also printed. We only have like consider the value 0 as the important value. Okay, so this is the important condition for this. Okay, so I can say from here I can say that I will write a condition that is if any adjacent vertex has flag value as 0, then that means we have cycle in our graph. Okay, I hope that ये condition समझ में आ गई होगी how you can detect a cycle in undirected graph. Okay, we have already seen the directed graph. Now it's time for undirected graph. So basically the thing is, here we are going to follow BFS traversal. So for BFS traversal we need a queue. So we will maintain a queue, we'll maintain a set. This will hold the BFS traversal. So basically C के बाद E and E के बाद D. So this is the BFS traversal of this graph. Now we have to know if that graph has a cycle or not. We are going to have a flag variable, or you can say a flag array of all the vertices, and for each and every vertex the value of flag variable can be -1, 0 or 1. Okay, here you can see the value can be -1, 0 or 1. So -1 will be the value, like initially सारी vertex की value -1 होगी because all the vertex are unvisited. Then the value will be 0 if it is visited and if it is inside the queue, and it will be 1 when it is out of the queue and visited and inside the set. Okay, and here you have seen once we start visiting this, when I came to E, when I was checking the adjacent vertices of E, so we have B and D. So B की value already 1 हो गई थी, so that was not a problem, that was not a thing that we have to worry about. When we saw D, D's value was 0, that means D is already present in the queue, and if any vertex is already presented in the queue, that means वो vertex किसी और vertex का भी neighbor हो चुका है इससे पहले. E से पहले किसी और vertex का neighbor हो चुका है D, that's why it is inside the queue, and we know that D is the neighbor of B already. So this means this conditions, when you find 0 as in the neighboring, in the adjacent vertex, when you find 0 as the flag value, that means we have cycle in our undirected graph. Okay, guys, quickly tell me if you have any doubt or anything like that. Can anyone tell me the time complexity? Can anyone tell me the time complexity of this? Time complexity? The time complexity of this will be V plus E, because we are going to see all the vertex once. Okay, हम सारी vertex को once देखेंगे and सारी edges को भी once देखेंगे. So the time complexity is going to be V plus E. And if I'll talk about space complexity, so the space complexity, we are going to maintain a queue, and in the worst case scenario this queue can be of size V because we are the vertex. And here again we are going to have a set, and in the worst case scenario the size of this set can go till OV. So we will have O of V only. Basically it's O of 2V, where 2 is the constant. So basically the space complexity is also O of V. Okay, if I want to know the edges also that are involved, the vertex also that are involved in the cycle, then I will also maintain a map which will have vertex and parent relation. Each vertex will be attached to its parent, and I can use that map the way I used in finding the cycle in directed graph. I used a map, right? So similarly I can use a map over here also, and that can help me in getting the vertex that are involved inside a cycle. Okay, so I hope that this thing is pretty clear to all of you. If any one of you have any doubt, you guys can quickly ask me, otherwise I'll just end the class. I think that everyone is pretty much clear with what I have taught, and I hope that you guys will learn a lot of things from me, and I'll see you next time. Bye bye everyone.